Hi everybody, this is WPC420. Got this bridge, quite a bit of erosion over here. I'm just gonna walk real quick on the other side of this bridge. Quickly look over here and get going. Maybe quite a bit more erosion down there. Alright, time to run. Well, this is WPC420. We can see quite a lot of erosion right here, which Sam saw actively falling, dirt falling from. So, yeah. So we sampled from right here. This is where we collected our samples. And we can see it meandering towards all those rocks, where it then goes under a bridge that has a road. So this is your full panorama. Hi guys, so we're at WPC420, and now that you've seen the panorama, we're gonna go ahead and take the samples. So I'm gonna go grab just a big beaker of water, and I'll bring it over here for Sam to do pH, conductivity, and alkalinity. Meanwhile, I'll go ahead and prep the samples that we'll be taking back to the lab. So we've got our water samples, beakers we just collected from the creek. We've got one for Sam,
yep,
and one for me for our sample prep.
Yeah, so what I'm doing right now is just calibrating the pH probe, fixing it with DI water, making sure we get good results. Starting with pH 4. You guys have all done this already, so you know what I'm talking about.
Meanwhile, I'm going to go ahead and label 2 test tubes, first for metals, so dissolved metals, which will be filtered, and then total metals, which will not be filtered. We also have an amber vial, which will filter samples for COD, anions, and then also dissolved organic carbon. I'm going to take the syringe and just rinse it out a couple times. I'm going to take this 0.45 micron filter and first just squeeze a little water out of it to flush out the filter. Then I'm going to go ahead and fill up this amber vial.
Cool. Alright, so I just finished calibrating it, so I'm just going to do a couple trials now. Test the pH of the water. Just 3, I think will do.
Three, that's pretty low.
Oh, 3 trials.
Oh.
Yeah.
I'm
not
listening.
3.
That is bad.
That would be not good. That's what we were getting during our field session.
Well, up in the mine site,
Yeah, it was a lot.
Alright, so we've got this label just on the baggie since amber vials are hard to write on.
And our first pH, 7.72. Not 3.
Not 3.
Very cool.
Oh, good.
Very cool.
So it's pretty turbid water here, so I already pretty much spent this filter. It was getting hard to push water through. So I'm going to go ahead and switch to a new filter now. And once again, just first flush that out real quick. Then I'm going to take my dissolved metals sample and fill that up. And I'm going to take my total metals, and this is just straight water. It's fine.
Over.
Alright, so now I'm going to jump down literally to the creek and fill these up. This is for fecal coliform, so this should be sterile. And I'm not going to open this up until I'm down by the creek and just quickly submerge it and put that cap back on so we don't get any contamination. This is for total suspended solids, so I'm also just going to take this down, fill it up, and we'll be good to go.
Alright, and I just finished up pH. So I'm just gonna, there we go, pop this guy back on. Here it goes. Oh, that is stiff. Cool, and next up I'm going to set up for conductivity. Good? You fall in?
I fell in a little bit.
No! Disaster!
Oh my god.
Just can't wear these sunglasses.
We're fine. We've come out of the creek and we've got our sample. It's always good to bring a trash bag to make sure you don't litter. So I'm just going to throw my syringes and filters back in here because we're not obviously reusing any of these at the other sites. And we'll keep this trash bag with us. Now lastly, we're just gonna put all our samples in the cooler to stay cold. Ideally, we could keep all of them in there, but if you want to prioritize, you should do your coliforms, your anions, and your DOC.
And then what I'm doing now is just calibrating the, what's it called again? Ionic?
Conductivity.
Conductivity, that's the word. Doing that one. A 1413 microcm per centimeter solution.
So ideally, I would wait for this conductivity measurement to decide what volume of alkalinity to use, but I'm just going to go ahead and send it, and I think I'll do the sample volume of 50 like we did in lab with Tom, and he might not be happy with that. Hopefully I made the right choice.
Fingers crossed.
I'm just gonna rinse this out since I have plenty of water. Just make sure speakers clean, quotation marks, with the sample. We've got 50 mils now.
It's taking a while.
Alright, so we're going to get our trusty hook that I can never get out of these little bottles. And I'm definitely contaminating with my glove. I'm going to do that 0.16 concentration of the acid. So this is a smaller concentration since I don't expect to need too much.
It's not calibrated.
Oh no.
It's getting there. Eventually. Alright, sweet.
Now this is always the hardest part for me, but I'm gonna try to get the air bubbles out without spraying acid all over Sam.
Oh, alright. I'll dodge it.
This hook seems kind of wonky. I don't know if
It
this is
does.
gonna work.
Then I'm doing the conductivity now. I got the calibration done. Just gonna do 3 of those, so we have 3 data points.
Always
range.
good for
Always good. You
triplicates.
never know.
Oh, good grief. This is, am I doing something wrong here?
These are brutal. Alright, first one is 309.
Nothing just can't go up because it's off filter. Oh, maybe that's gonna work. Hopefully.
If we're lucky.
Ah! Come on. Ah! So if you're spraying acid everywhere, it usually means you're doing it right.
Woo.
And you want to hold it vertical so you get those air bubbles out. So now I know I'm not seeing any air bubbles, so I think I'm good to go. I need to remember to reset the digits that we covered with Tom. So it's at 0 now, and I can start titrating. I'm trying to remember, was it methyl green?
Yeah, I think so.
Not phenol. I'm pretty sure it's methyl green. That's the lower pH bound.
Yeah, it was green in the video.
Perfect. Sorry, Tom. Alkalinity is not my strong point.
Thanks. I've just finished up conductivity. I'll pack all this stuff up.
And you'll notice that Sam has been writing in our trusty notebook.
Oh yeah.
So we're good to run as soon as we're done here, and then we'll more officially fill out the chain of custody and all of that good stuff once we're not out here in the field. We can think more level-headedly.
Alright.
Not getting eaten alive by mosquitoes is nice too.
Oh, I'm being good. They're not going after me. It's working out great over here.
I'm your mosquito trap.
It's great. Can't complain.
So what was our conductivity?
So our conductivity was all around pretty much 309.
So I'm pretty sure I made the right decision. We'll see here on alkalinity then. I can tell we're getting close. If you find that you're titrating forever, you probably either made the wrong decision with the concentration of acid and or your volume.
Alright, since we're done with this, I can just pack it up. I didn't need to say that.
So this is WPC420. We can see quite a lot of erosion right here, which Sam saw actively falling, dirt falling from. So we sampled from right here. This is where we collected our samples. And we can see it meandering towards all those rocks, where it then goes under a bridge that has a road. So this is your full panorama. And we're gonna get out of here. We found a pretty good spot on the other side of the bridge for WPC420. So this is where we are. You can see this interesting grate that's stopping a lot of branches. It looks like we have a fence post, some T-posts, all that stuff. So that's pretty interesting. There's also quite a few cows around here. We've got some cow poop, so it'll be interesting to see what the coliform count is. You might see a lot of nitrogen, who knows? So things to keep in mind for WPC420. Hi guys, so this is JC220. We've sampled right here. It's just nice meandering flow right now. We're gonna go ahead and cross the street real quick. Just look at the other side. All right, so this is the other side of JC220. Again, it's kind of more of a marsh here. So depending on the retention time here, we might see a lot of organic carbon just from the water kind of sitting here in this soil, in the grass. Who knows what else is going on around here. So organic carbon will be interesting to look at as well. And then here's the bridge where it goes over to the other side where we sampled. So yeah, there we go, guys. Here's, we're getting close to the confluence. And this is just a really interesting, I think you call this the classic horseshoe, where the meandering creek is about to intercept itself with the horseshoe shape. But yeah, we're seeing a lot of signs of erosion here. Alrighty, we are at the confluence. Pretty sure this is West Plum. Check me when you look at your map, but coming from the right or the east, we have, we think West Plum Creek.
The right.
And then Jackson from the west or the left on for me is Jackson Creek. And we have our confluence here with a lovely table going on. I don't know if you can see it in the middle there. So yeah, well, we're gonna move up here, look at this erosion we've got going on for the stream bank assessment. And we've got quite a lot going on here. Similar to what we saw earlier, just quite a lot of erosion. A lot of trees and vegetation, which you want to take into account. That there is the beavers.
Oh.
Tree. Bit that good. Alright, so I just noticed we've got a nice little beaver dam here, it looks like. That is what trapped our table and chairs. So it looks like kind of a succession of beaver dams we've got here. So there's a lot of signs of beavers. Again, the fecal coliforms might be interesting thanks to the beavers. But things to keep in mind that their dams are kind of damming up the two creeks here. So we're sampling past the beaver dam where we know there's probably been pretty good mixing of both creeks. So hopefully this will be a representative sample of what you would see downstream past this confluence. So be sure to thank Sam for grabbing your sample for this one.